Swayam Prabha. Digital India. Educated India.
We have discussed the working principle of multilayered feed-forward networks and radial basis function network, and we have seen how to model the input-output relationship of a particular process. But supposing that the process is highly dynamic. Now, for a very dynamic process, so these networks may not be able to capture the dynamics of them. Now, in that case, if you want to make a successful model, we will have to go for another type of network, which is known as the recurrent network. Now, this recurrent network, so this is in short, so this is known as your RNN. So, recurrent network is known as the RNN. Now, we are going to discuss in details the working principle of these particular the recurrent neural networks. Now, before I go for the recurrent neural network, we should try to understand the reason behind going for this type of network in more details. Now, to explain that fact that why should you go for this type of network, let me try to take one very practical example. Now, supposing that I am going to model a process, the process is something like your straight turning of a cylindrical part. Now, supposing that I have got a cylindrical part something like this. Now, this particular cylindrical part I will have to make one turned cylindrical part, and supposing that I will have to make something like this. Now, for getting this type of product starting from here, so I will have to go for the straight turning. Now, this straight turning that is carried out on a lathe. Now, if I just go for this particular straight turning, so what I will have to do is, so I will have to consider a process which is having 3 inputs at least, say cutting speed, feed and depth of cut. Say cutting speed is denoted by say V, feed is denoted by F, and your depth of cut is denoted by D. And what are the outputs? The outputs are nothing but the quality of the turned surface, and that is measured in terms of say surface roughness, say it is denoted by small s, and supposing that I will have to find out what is the power consumption, so that is denoted by P. Now, let me repeat. So, this is a process of say straight turning, and this particular straight turning has to be carried out on a lathe, and here there are 3 inputs like cutting speed, feed and depth of cut, and the outputs are the surface roughness and the power consumption. Now, these inputs are selected by the user or the operator, and we do the turning, and then as a result I will be getting some surface roughness and the power consumption. Now, the moment we select this input parameter, something else happens inside this particular process. Now, if I call, so these input parameters are nothing but the external input parameters, and the moment we select these external input parameters, some of the internal input parameters will be created. For example, say there will be some level of vibration while doing this particular the machining. Now, this generated vibration, that is called the internal input, that is IIN. So, these particular internal inputs will have some contributions towards the surface roughness and the power consumption. Now, if I want to model, so this particular dynamic process in a very efficient way, so we will have to consider both the external input as well as the internal input because both of them are having some contribution towards the output. Now, the network which we have already discussed, like your multi-layered feed forward network or the radial basis function network, cannot be used to capture the whole dynamics of this particular the process. Now, if I want to capture the complete dynamics of this particular process, so we will have to go for in fact the recurrent neural networks, and that is your RNN. Now, before I discuss the working principle of this particular RNN, let me try to concentrate on how to capture the dynamics of a particular layer of neurons. Now, let us try to concentrate on this. Now, for simplicity, let me consider that on a layer of a neural network, say I have got only 4 neurons, say 1, 2, 3 and 4. Now, what we do is to find out the output of this particular the first neuron. So, the input should come from the second, third and fourth. So, input is coming from your, so this particular neuron, then it is coming from your, so this particular neuron, and it is coming from this. So, the inputs are coming from, so these 3, and we will be getting some output here. Now, this particular output will be fed back. So, this particular symbol Z inverse, that indicates the feedback. So, this will be feedback actually to the second neuron, then comes your the third neuron, and it will also go to the fourth neuron. Now, let us concentrate on the second neuron. The inputs of the second neuron should come from the first one, then comes your the third one and the fourth one, and supposing that this is the output we are getting. Now, this output will be fed back, and this will come here, and this particular output will enter the first neuron, then comes it will enter your the third neuron, and it will also enter the fourth neuron. Now, let us concentrate on the third one. Now, the output which you are getting from the third, so that will be fed back, and that will enter to the first neuron, and then it will also enter to the second neuron, and this will also go to the fourth one. And let us concentrate on the fourth neuron. So, the output of the fourth neuron, that will be fed back, and that will enter in fact the first neuron, then it will enter the second neuron, and then it will enter the third neuron. Now, this is the way actually we try to capture the dynamics of this particular the layer of neural network, and this particular layer, for simplicity we have assumed that it consists of only the 4 neurons. Now, to summarize, let me mention that in this type of recurrent network, so what we do is we take the help of some sort of feedback. Now, this feedback is actually is going to help us to capture the dynamics of this particular the process, and here there will be a cycle or a loop in this type of network. So, this is actually the way we can capture the dynamics of a single layer of this particular the neuron. Now, we are going to concentrate on the network, that means it has got say 3 layers like input layer, hidden layer and output layer. Now, here if you see the literature for this particular the recurrent neural networks, we have got a few very popular models. For example, say we have got L1 model, then comes we have got the Jordan network and the combined L1 and Jordan network. Now, let me concentrate first on this particular the L1 network. Let us see how does it work. Now, in this type of network, in fact, we have got 2 circuits. One is the feed forward, and another is called the feedback circuit. So, we have got feed forward and feedback circuit. Now, if I concentrate on this particular input layer, so the external inputs, so that will be passed to the network through this input layer. So, this is the input layer. Now, we have got the connecting wires between the input layer and the hidden layer, and that is denoted by V, and on the hidden layer. So, these neurons are having some transfer function, and depending on this particular transfer function, so I will be getting some output here, I will be getting some output here. Now, here actually what we do is, so these output of the hidden neurons or the hidden layers, those are not directly passed to the output. Instead, those outputs of the hidden neurons are taken as the feedback. So, the output here for this particular hidden neuron, so that is actually taken back as the feedback, and what we do is the output which you are getting, either we consider the 100% of that, or say might be say 50% or 30% or 40% of that as feedback, and we just keep it here. Now, similarly, the output which you are getting on this particular hidden neuron, so that we take as actually a feedback, and once again, so we just copy and we put it here. Now, these actually the feedbacks are nothing but the internal inputs of this particular process denoted by IIN. So, here we pass the external inputs, and these internal inputs will be generated inside this particular process, and now actually what we do is we try to pass actually all such inputs once again to the network, and what we do is, so this particular the feedback that will be allowed to come here, and this particular feedback will be coming here, and of course, we are having these particular circuits also, and here we will be getting actually the combined input for this hidden neuron. Now, similarly, here also I will be getting, so this particular feedback is coming from here, this particular feedback is coming from here, and of course, so this will come, this will also come. So, here I will be getting this combined input for the hidden neuron, and these particular combined input will be passed through the hidden neurons, and then I will be getting this particular your output. Here I will be getting this particular output, and whatever output we get here, so whatever output we get here, we multiply by the connecting weights, that is denoted by the W, and here we will be getting the combined input for the output layer, the combined input for the output layer, and the output layer neurons are having some transfer function. So, I will be getting this particular the final output that completes actually one iteration of this particular the network. Now, here to summarize, actually what we do is we take the feedback from this particular the hidden layer, and either we consider 100% of this output of the hidden layer or slightly less than 100% as feedback, and this feedback will be actually considered as input to the hidden layer once again, and then it is passed, and ultimately we will be getting this particular the output. Now, if you see, so this particular network consists of in fact two such components. One is called the feed forward component. So, this is nothing but the feed forward component, and this particular component is nothing but the feedback component. So, this network has got both the components, and it will be able to capture the dynamics, and this is actually this shows the working principle of this L1 network. Now, so as I have already mentioned several times that it will be preferred to the multi-layered feed forward network if we want to model a highly dynamic process. So, this is the working principle, and now I am just going for the another the recurrent network, that is called the Jordan network. Now, in Jordan network, actually what we do is we take the feedback from the output layer, but we do not take the feedback from the hidden layer. Now, once again let me start. So, I am passing So, one set of external inputs denoted by say I E x, and here we have got the connecting weights. So, whatever output we are getting here and here, so those things will be multiplied by, so these connecting weights, these are the connecting weights V, and those things will be summed up here. So, I will be getting some input, I will be getting some input here, and initially we assume that, so this particular feedback circuit is not present. Now, I will be getting, so the inputs, and we will pass it through the neurons of this hidden layer. So, depending on this particular transfer function, so I will be getting some output here, and similarly here also for this particular the hidden neuron. So, I will be getting some output. Now, this output will be multiplied by the connecting weight, this will be multiplied by the connecting weight, and those things will be summed up, and this will be considered as input of the output layer. Similarly, this will be multiplied by this connecting weight, this will be multiplied by this connecting weight, and those things are summed up, and these are nothing but the input for the output neuron. And depending on the transfer function, so we will be getting some your output here, and we will be getting some output here, but these outputs are not actually the final output. Now, what we do is, so instead of going for here, so this output actually we fed back, and this will be used as your some sort of feedback to this particular the network. And similarly, whatever output we are getting here, so these particular things will be fed back, and it will be used as the internal inputs. Now, here we will be and here we will be getting some internal inputs. Now, those internal inputs will now be passed through this particular the network, and that means you will be getting some feedback. So, this feedback will come, and here, so this particular feedback will go, and I will be getting the feedback here, I will be getting the feedback here. Now, we are in a position to determine what should be the combined input for this particular the hidden neuron, and we will be able to find out what should be the combined input for this particular the hidden neuron. Now, depending on the transfer function, I will be getting the output, I will be getting the output, and once again we use this particular the connecting weights, then we will be getting the combined input here, combined input for this particular output neuron, and then using the transfer function I will be getting the final output, I will be getting the final output here. So, that completes actually one cycle or one loop or one iteration of this particular the network. Now, to summarize, so in Jordan network we take the feedback from the output layer, and as I have already mentioned, so this part is nothing but the feedback circuit, and this is the feed forward circuit, and in this type of RNN we consider both the feed forward circuit as well as the feedback circuit, and ultimately for a set of external inputs I will be getting the final output, and of course, it is the system is going to generate, so this type of your internal inputs. Now, for the purpose of calculating the outputs, feedback and all such things, exactly the same procedure which we have discussed for the multi-layered feed forward network, like how to find out the inputs for a particular layer, how to find out the output and all such things, exactly the same principle we can follow. Now, actually we are going to discuss another network which is the combination of this particular the Elman network and the Jordan network. Now, here in Elman and Jordan network combined form, we take the feedback both from the hidden layer as well as from the output layer, and let us see how does it work. Now, let me assume that initially, so this particular feedback, say it is not there. So, let me assume that this particular feedback is not there, and let me concentrate on the feed forward circuit first. Now, I am passing the set of the inputs, that is nothing but your external inputs exactly the same way the way I discussed. So, here on the input layer we have got the neurons, they are having their transfer function, and based on that particular you will be getting some output here. And once you have got this particular output, now this output will be multiplied with the connecting weight. So, I am here, this will be multiplied with the connecting weight. So, I am here. Similarly, this will be multiplied by the connecting weight, this will be multiplied by the connecting weight. So, I will be getting some input for this hidden layer, I will be getting some input for this particular the hidden layer. Now, I will pass. So, these inputs to the hidden layer. So, I will be getting some output here, and I will be getting some output, I will be getting some output. Now, what I do is, so this particular output has got now two applications. One is it will be allowed to pass to the output layer, and this particular output will also be allowed to enter. So, this particular the feedback circuit. Now, let us see like what happens if it goes to the feed forward circuit. So, this output will be multiplied by the connecting weight, this output will be multiplied by connecting weight. So, I will be getting some combined input here and here. So, this particular output will be multiplied by your the connecting weight. So, this will be multiplied with the connecting weight, and those are summed up, and these inputs are going to pass through the output neurons, and here we have got the transfer function. So, I will be getting some output here, I will be getting some output here. Now, what I do is, so this particular output we consider either 100% or less than 100% of that as feedback. So, this will be used as feedback. So, this is the feedback and it will be stored here. Now, similarly, so this particular the output will be considered as feedback and it will be stored here, and let us concentrate on the output of this particular your the hidden layer. Now, if you concentrate on the output of the hidden layer, so you can see that we have got the output of the hidden layer, which is nothing but this. So, this will be used as feedback. So, I am just going to use that feedback and it will be stored here. Similarly, the output of this particular hidden neuron, so this will be allowed to pass through like this and will be able to collect here in this particular the neuron. So, this is the way actually we collect the combined feedbacks both from your hidden layer as well as the output layer, and here we will be getting that particular your internal inputs. Now, these internal inputs will be allowed to pass through this particular hidden layer. So, I am just going to pass it here, I am just going to pass it here, and similarly this will be allowed to enter. So, this particular hidden neuron, and this will be allowed to enter this particular the hidden neuron. So, what happens here, I will be getting this particular the combined input for the hidden layer, I will be getting the combined input for this hidden layer, and these combined inputs will be passed to the transfer function here and the transfer function here. So, I will be getting the output here, I will be getting the output here. Now, the output which you are getting, so that will be multiplied by the connecting weight, multiplied by the connecting weight, this output will be multiplied with the connecting weight and connecting weight, and so these things we are going to collect here. So, these inputs for the output neuron we are going to collect, and these inputs will pass through the transfer function, and ultimately we will be getting the final output of this particular the network, and this completes actually the one cycle of your this particular the combined Ullmann and Jordan network. Now, this is the way actually we capture the dynamics of this particular process, and as I mentioned, so this is the feedback circuit and this is the feed forward circuit, and both the things will be working together and we will be getting this combined Ullmann and Jordan network. Now, if you see the performance of this particular network is found to be very reliable. Like if you want to model the dynamics of a highly complex or highly dynamic process. Now, as it is having this feedback circuit, so there is almost a guarantee that it will be able to capture the dynamics of this highly dynamic process. Now, if you see the computational complexity of these particular the networks, here as it is having both feedback and feed forward circuits. So, compared to your multi-layered feed forward network, here there will be more computation. So, computationally it could be little bit more complex, and moreover as we have discussed, the Elman network, Jordan network and the combined Elman and Jordan network, if we compare their computational complexity, the computational complexity of the combined Elman and Jordan network is obviously becoming more compared to that of only Elman network and only Jordan network. But supposing that we have got a very complex process, very dynamic process, so is better to go for this type of combined Elman and Jordan network. So, the working principle of these particular the recurrent network we have discussed, and principle wise it is very simple, and this network is actually it has been reported that this network can perform very well, particularly to capture the dynamics of the highly dynamic process. Thank you.